So to go off of the last video, I'm going to do an example that is just like those steps that we followed when we did solving multi-step equations in 8th grade, except for this first one I'm going to do might seem a little bit tricky because of what the solution ends up being. And then the next three, you can't really follow those steps exactly. So I just want to go over them so we can have exposure to different types of problems. So this first equation, we're following our exact same steps. So my first step is to write down my equation and draw my line. My second step, and I'm going to cover up the right side of the equation, is to simplify the left side. So I'm going to follow what I know about simplifying expressions, and I'm going to simplify this left side. I did the distributive property. Now that I've done that, I can combine like terms. And once I combine like terms, then there's nothing else I can do with this side, and I can move on to step number 3, which is to simplify my right side. When I simplify this right side, I'm going to do the distributive property, and I get negative 1x, or just negative x, and then negative 1 times positive 24 gets me a negative 24. Now I can look at the entire problem, now that I have both sides as simple as possible. I want these in line with one another, so I'm just going to write this one down one row so that they're in line with each other. And I'm going to square my variable terms and circle my constants. My next step is going to be to add or subtract so that our variables are on one side of the equation. For me, I would rather add than subtract because I would rather work with positive numbers. Oops, this should be plus x. I don't know, I was going to draw like a 24. And then I'm going to add x to this side. The reason I'm adding 1x is I want this square to go away. So the opposite of negative 1x or negative x is positive 1x. So those cancel out and get to 0. On my left side, I have x plus x, which gives me 2x. I have to bring down this negative 24, and I bring down this negative 24. And then I can draw my circles and my squares again. Now I'm just dealing with the two-step equation. So I want circles and squares on opposite sides before I can do multiplication and division. So what I'm going to do is add 24 so that I can get rid of this negative 24 that shares a side with my 2x. And when I do that, I actually get 2x equals 0. A lot of the times people will want to say that this is no solution, but that's not true because I still have this x here. So what I can do is just proceed to my next step, which would be to divide by my coefficient. So I'm going to divide 2x by 2. I'm going to do that to the other side as well. And when I do that, if I do 0 divided by 2, that just gives me 0. So I know that x equals 0. There is a solution. The solution is just 0. So that's one of our kind of trickier problems we can look at when solving multi-step equations. We can also have fractions, and I know we all love fractions. So let's look at this, what I think is a little bit simpler version of a fraction problem because it is just a two-step problem. So if I'm looking at this equation, what I'm going to do first, like always, is I'm going to draw this line. Both sides of my equation are already simplified. So now what I'm going to do is square my terms that have a variable and circle the constants. My square is on the left side, so I want to get rid of the circle that's on the same side because we don't want our variable terms and our constant on the same side. We want them separate. So I'm going to subtract 15 from both sides. When I do that, On the left side, I'm left with just 6/7 x. And on the right side, I have -18. I'm going to switch to a darker color, maybe red. Now, what we can see is that we actually do have a coefficient that is attached to our x. So what I would do here is I would divide by the coefficient, because that's what I do when we're trying to undo multiplication, and there's an invisible multiplication sign here. So if I divide both sides by 6/7, we're going to think of a rule that we use when we're dividing fractions. And that rule is keep, change, flip. So what I'm going to do when I divide -18 by 6/7 is I'm going to keep my -18. I'm going to change my division sign to a multiplication sign, and I'm going to flip my fraction. And when I do that, I can do -18 times 7 and get -126. I do 1 times 6 and I get 6. And then I can simplify this and get -21. So then I know in my problem, after I have divided -18 by 6/7, I have my answer, which is -21. So let's look at a couple more problems that use fractions. So my other two problems we have are -8 equals -a minus 12 over 4, and then we've got this problem over here. So let's start with number 3, because number 3 is a little bit simpler than number 4. So number 3 is only tricky because we have this division that needs to take place before this subtraction, because this division is happening to everything in the numerator. So if I remove this -12 from it, then it's just not correct anymore, because I know that -a minus 12 is all over 4. But what I can do to get rid of this over 4 is multiply by 4 over 1. Because if I multiply by 4, that gets rid of our divided by 4. And if I do that to that side, I have to also do it to this side. And those cancel each other out. And I am left, oh, I did not draw my line. Make sure you draw your line. On this side, I'm just left with -a minus 12, because the 4 canceled out, equals -8 times 4, which is -32. And now that I'm not dealing with a fraction anymore, hopefully it looks a little less intimidating, and I can add 12 to both sides. These cancel out. I'll bring down my -a, and -32 plus 12 gets me to -20. And then I have to divide by that coefficient that is attached to my a, which is a -1. And I'm left with a equals 20. There are a ton of different ways to practice problems like this, to solve them. You can approach it in a lot of different ways. I think this way is the easiest. Another way would be to split up your fraction. Another way would be to make this division problem, put the fraction in front. There are just a lot of different ways we can look at it. For the sake of this video, this is the way I'm going to stick with, and hopefully it works for you. Looking at number 4, a lot of people would rather look at decimals than fractions. So what I'm going to do for number 4 is I'm actually going to show you how I would solve this problem when I'm looking at decimals rather than fractions. So what I know is that 7/5 is really the same thing as 1.4 because 7 divided by 5 is 1.4. So what I'm going to do is change these. And again, I'm skipping this important step, sorry. I changed this to the decimal form. A over 10 is the same thing as 1/10 A or 0.1 A. For right now, I'm just going to use 1/10 A because I don't want to change too much in one step. And then I need to figure out what 23 over 5 is as a decimal, and it's 4.6. So for me, this is a lot easier to look at than this one. And now I can just use my normal steps. So I'm going to circle my constants and box my variable terms. I'm going to add or subtract so that my variable term is on a side by itself. I'm going to bring down this 1/10 A. And then we've got 6.0 equals 1/10 A. And if I remember something, it's that dividing by a fraction is really the same thing as multiplying by something called the reciprocal. So if I'm dividing by 1/10, it's the same thing as multiplying by the reciprocal, which is just a fancy way of saying keep, change, flip. So I've kept my 6, I changed my division sign to be a multiplication sign, and I flipped my fraction. When I do that, I get 60 over 1, which is just 60.